Okay, so let's move into a new topic known as the chain rule. We're still working with derivatives in this particular section. So before I get into this rule over here, I want to talk about a derivative that we have taken in the past by just using the power rule. If we had a function x to the third, we know that the derivative of this function would be 3x squared, right? And we would leave it alone. Now, here's something you need to understand. When we took the derivative of this x to the third, all we really looked at was taking the power, bringing it down, and reducing it by 1. Do you notice we never really even dealt with the x? So, let me ask you something. If I'm trying to find the derivative of x, right, that would mean, and by the way, x is to the power of 1, agreed? That would mean that if I took this, the 1 comes down, and the power on the x gets reduced by 1, which means this would be 1 times x to the 0, or just 1. Interestingly enough, the derivative of x is just 1. Which is why we never really looked at the x. We just said, oh, the derivative of x to the third is 3x squared, and so be it. When in actuality, we should have, after we took the power down and reduced by 1, we should have looked at taking the derivative of x also, which would have made our work look like 1, which still just gives us 3x squared. So if I look at taking the derivative of x, the base, right, because x is known as the base since it has a power, and all I get is 1, it never really changes my answer. But if your base is not a 1, it's going to start changing your answer a little bit. You with me? If this x is something else, like in parentheses 2x plus 3, then that's going to change your answer because now I've got to look at something else. This extended power rule says that suppose that g of x is a differentiable function of x, then for any real number k, I've got the function to a power. To find the derivative of this, I am going to bring the power down, reduce the power by 1, but then I am going to multiply this by the derivative of the function itself. Then I'm going to take the derivative, or multiply it by the derivative itself. You're like, can you help me out there? Yes, let's do an example. Suppose the function is 2x plus 1 to the power of 3. If I look at this derivative, you're like, okay, well, I take the power down, and then I reduce the power by 1. And you're absolutely correct. You do that. However, my base here is not just an x. If my base was just an x, then I would just be multiplying by 1. But my base here is 2x plus 1. So now I really have to pay attention and finish off the derivative of this original function by multiplying by the derivative of the base. I bring the power down, I reduce the power by 1, and now I've got to look at the base here and take the derivative of it. And when I do that, I am going to get 3, and in parentheses 2x plus 1 to the power of 2. And now it is going to get multiplied by what? What's the derivative of this? Yeah, the derivative is 2. when your base is just an x, the derivative is always 1. It doesn't change it. But that 2 is certainly going to change things, because in front isn't a 3. In front would be 3 times 2, which is actually 6. This is actually the derivative of this function. With me? We have to take an extra step. And the extra step is take the derivative of the base. If your base is just x, no big deal. It's always a 1. But if your base is something other than x, it is going to change the final outcome. So stay tuned. I've got some examples on how to apply the extended. So let's look at the second problem. I'm still taking the derivative, which means the first thing I'm going to do is I'm going to bring down the power, which is negative 40, and then I'm going to reduce it by 1, which makes it a negative 41. Agreed? But I'm not done in this particular case. Why? The base is not just an x. The base is 8x squared minus 6, which means I am going to have to take this and multiply it by the derivative of 8x squared minus 6. With me? Okay. Which means we have negative 40, and in parentheses the base to the exponent of negative 41, and then we multiply by the derivative of the 8x squared minus 6. So what's the derivative of 8x squared minus 6? Good, that would just be 16x, which means my answer is going to look like the derivative. Now, I'm going to multiply what I can. I can take the negative 40 and I can multiply it by the 16x, can't I? So, we have to do 4 times 16, don't we? So what's 4 times 16? Yeah, or I should say 40 times 16. So I got negative 640x, and in parentheses, 8x squared minus 6, and that's to the negative 41st power. Good? Yeah, the base not being just an x is going to change our answer. Okay, let's look at number 3. Number 3 is like a two-parter. So here's what I'm going to do. I am going to take the derivative of this first part, and then the derivative of the second part, and then I'm going to bring them together. Because since they're attached by subtraction, subtraction lets me look at the two pieces separately and then bring the two answers back together. So, let's look at finding the derivative of the 3 plus x to the third to the power of 5. To find that derivative, what do we do first? Yeah, we bring down the 5 and we reduce it by 1, which is going to give us a 4. Now the question you ask yourself is this base an x? Nope, it's not. So that means you're going to take this and you are going to multiply it by the derivative of 3 plus x to the power of 3. Okay, so 5, and in parentheses 3 plus x cubed to the power of 4. What do you get when you take the derivative of 3 plus x to the third? Good, you just get 3x squared, right? Okay, so let's finalize this derivative. Gratefully, I can do 5 times the 3x squared, which is going to give me 15 x to the second times the quantity of 3 plus x to the third to the power of 4. That is the derivative of just this first part. Okay? Okay, and now I got to deal with the derivative of the other one. So the derivative of the other one is going to look like we're dealing with 1 plus x to the 7th to the power of 4. So when I look at its derivative, what do we do first? Good, we bring down the 4. We reduce it by 1, which is going to give us a 3. Now the question is my base just an x? Nope, it's not, which means I'm going to have to multiply by the derivative of 1 plus x to the 7th. Right? Okay, so this is still a 4, and in parentheses 1 plus x to the 7th to the power of 3, and you're going to take that and you're going to multiply by the derivative of this guy. So what's the derivative of 1 plus x to the 7th? Good, 7x to the power of 6. So let's finalize this one. I can take the 4 and multiply it by this, can't I? So we're going to get 28 x to the power of 6 multiplied by the parentheses of 1 plus x to the 7th to the power of 3. Okay. Quite interesting, isn't it? Time to put the answer together. So my derivative of the function is going to be equal to, and I am going to write it underneath. Why? Because I'm running out of board space. 15x squared, and in parentheses, 3 plus x to the 3rd to the power of 4 minus the other one, which was 28 x to the 6th, and in parentheses, 1 plus x to the 7th to the power of 3. The chain rule isn't bad. What you have to be careful of is when they start putting pieces together like this, you really have to take it slow. This is why, since it's attached by subtraction, I just looked at the derivative of this first piece, and then I looked at the derivative of the second piece, and then I was able to put them back together with the minus sign in the middle, which made it a lot easier to deal with than trying to work out the derivatives at the same time. Cool? And I know some of you are going, are you ever going to have to work out the derivatives at the same time? Well, if it's the original problem is multiplication or division, I am. But hang in there. We'll get to those. So let's look at this fourth example. We're still being asked to take the derivative. And notice I have an addition sign between these, which means I can look at them separately, which is actually going to make our lives a lot easier. So I'm going to write the first one over here and then the second one over here, and then we're going to work on the derivative of each one. So if we look at the cubed root of 2x minus 1, remember, there's another way of writing the cubed root, and that is writing it as a power. And when I write it as a power, it's going to make things a whole lot easier. So as I take the derivative of this, the power comes down. We reduce the power by 1. But remember, now you have to take the derivative of the base. And this becomes a multiplication problem. So what would be the derivative of 2x minus 1? Yeah, just 2, right? Because the 1 is a constant, so it goes away, and the derivative of x is just 1. So this becomes 1/3, in parentheses 2x minus 1 to the negative 2/3 power, times 2. Cool? Okay, so let's simplify this. We'll actually have 2/3, and this negative, so I'm going to write this just a little bit bigger. This negative exponent means that the 2x minus 1 belongs where? Yeah, it belongs in the denominator. So I've got 2 over 3, and in the denominator is the 2x minus 1. It is still to the cubed root, but it is also to the second power. Cool? Okay, it is to the cubed root, or it is the cubed root of this, but it is also to the power of 2. Good? Are you with me? Okay, Another way of writing that second power, we have 2 over 3. We've got the cubed root, and I can write 2x minus 1 under the cubed root squared. So that's another way I could literally write that second power with that cubed root. Either on the outside or the inside. Makes no difference, it's the same. Cool? Okay, we still have to deal with this one over here. This one isn't so bad though, right? I don't have a root to deal with. So I am looking at taking the derivative of 4 minus x to the power of 2. So what do I do first? Good, we bring the power down. We reduce it by 1, which will take it to the power of 1. And then, yeah, you have to take the derivative of the base of 4 minus x. Okay, so what's the derivative of 4 minus x? Well, the derivative of the 4 will be 0, and the derivative of x will be 1. But it's going to be a negative 1, agreed? Because it was a negative x. So this one simplifies to negative 2, and in parentheses 4 minus x. Or, because this one is simple enough, I could literally write negative 8 plus 2x, and that'll be okay also. Agreed? Okay, so remember, when you have an addition sign between them, you take them individually, or a subtraction sign, you take them individually, and then finally, we get to put them back together. So, our derivative of g of x, so g prime of x is going to be equal to, the derivative of this cubed root is 2 over 3 times the cubed root, and underneath it is the 2x minus 1 squared, plus, or minus in this case, because we have to write the minus 8 first, or you could write the plus 2x first, it really doesn't matter. But I'm just going to leave it in the order that we had written it up here. Here is our derivative of this function. Cool? You with me? So here's the deal. It's something we already know. You have to deal with the power rule. And then the extra step is actually taking the derivative of what the power is sitting on, which is technically called the base. Got it? Okay, so no surprise, got another example. All right, so let's look at this fifth problem. They still want us to take the derivative of this function. Now here's the deal in this case. This function happens to be a product. Agreed? And I don't have to, but I have this negative 5x, and I can put it in parentheses if I choose, and it's being multiplied by this 2x minus 3, and the quantity, means parentheses, is raised to the power of 4. So in this particular case, to take the derivative of y, we need to use the product rule. So let's see what you remember. Okay, so to take the derivative, what's the first thing I do? Good. I take the derivative of the first one, right? Do nothing with the second one. Add to it, right, the first part, and then, that's right, take the derivative of the second part. With me? Okay, so now, to find the derivative of y, we have to take the derivative of negative 5x, which would be, good, just a negative 5 here. And that's going to get multiplied by the, in parentheses, 2x minus 3 to the power of 4. Remember, we're not doing anything to that. And then plus, and over here after the addition sign, the negative 5x we're not doing anything with. And then we're taking the derivative of, right, this exponent. So, first things first, what do we do here to take the derivative of this base to a power? We bring the power down, we reduce by 1, And then, that's right, multiply by the derivative of the base. And yes, I'm doing it in one step at a time so we can see what's going on here and we don't make a mistake. Got it? Okay, so back over here. So the derivative of y, we have this negative 5 times the parentheses of 2x minus 3 to the power of 4 plus, now I have this negative 5x times 4, agreed? And then to this multiplied by this parenthesis to the power of 3. So can't I take the negative 5x and multiply by 4? Yeah, because it's just a multiplication problem, right? So we have the negative 20x and in parentheses the 2x minus 3 to the power of 3. And then, yeah, we got to take the derivative of this guy. So what's the derivative of 2x minus 3? Excellent. Just 2. So how's it going so far? You with me? All right. Okay, so y prime equals, here's our negative 5 times the parentheses of 2x minus 3 to the power of 4 plus, okay, so I see this negative 20x being multiplied by the parenthesis, which is also multiplied by the 2. So this whole thing is a multiplication problem. Couldn't I multiply the negative 20x times the 2? Excellent. So that'll give me a negative 40x and in parentheses 2x minus 3 to the power of 3. Got it? Okay, so now, if you look, these two are not the same, so you can't add them. And you're like, well, I am not writing this out 3 times and multiplying it together. And yeah, I wouldn't do that either. I'm going to be honest with you. But we can do something to simplify this problem. And at first glance, it's not very obvious, but here's something to pay attention to. Do you notice the first term has this 2x minus 3, and the second term also has the 2x minus 3. So they have that in common, don't they? Well, that means I can factor out a greatest common factor. So I actually have a GCF here, which, when I factor it out, will hopefully make the leftover simple to simplify. Okay, so the 2x minus 3 is in common with both terms. How many of them? If this one has 4 and this one has 3, how many 2x minus 3's do they have in common? Good, they've got 3 of them in common. So our greatest common factor is 2x minus 3 to the power of 3. Because this one only has 3 to give. This one has more to give, but I can't take any more than this one has because this is the smaller amount, right? Okay. So, and by the way, if you just want to watch at this point, that's totally fine. Just watch. So, y prime is equal to, I am going to factor out that greatest common factor of 2x minus 3 to the power of 3. So let's look at this first term, right? This first term, when I take out the 2x minus 3, I'm taking out 3 of them, right? Okay, so let's see, what's definitely going to remain? Yeah, the negative 5 is definitely going to remain. Now, this has 4 of those 2x minus 3's. You're taking 3 of them out. How many remains? Good, just 1 of them. And here's that just 1 of them. Good? Okay, on this second term, plus the negative 40x will definitely remain. Agreed? All right, now remember, you're taking out 2x minus 3 and you're taking out 3 of them. From this term, when you take out the 2x minus 3 and you take out 3 of them, is there any left? Nope, nothing is left there. In parentheses here is the leftover when you factor out this greatest common factor of the 2x minus 3 in parentheses to the power of 3. Cool? Okay, so let's see what this looks like. So y prime is equal to my greatest common factor of 2x minus 3 to the power of 3. And now we get to simplify in this bracket, which actually looks pretty easy to simplify. It doesn't look too bad, actually. So yay for that, right? Okay, and then one more line, it looks like, at least one more line. So it looks like we have a negative 50x plus the 15, right? Hey, that's pretty good. That's pretty nice. And here's the deal. In the parentheses, there's still something in common. You're like, how do you know when you're done? Okay. So when you're at this point and you notice that you can't combine the like terms without writing these guys out a few times, then you're going to try to factor out what's in common. Now at this point, it was very obvious to factor out the 2x minus 3 in parentheses to the power of 3. Had I paid closer attention, I would have noticed that out of the negative 5 and out of the negative 40x, I could have factored out a negative 5. But I didn't pay as close attention as I could have. But that's okay, because right here, I'm noticing that I can factor out a negative 5. So whether I notice it up here or down here, it doesn't matter. It's the same thing. So I am going to y prime. I'm going to, from here, divide out a negative 5. We still have the original GCF. And out of here, when I divide a negative 5 out, what do I get here out of negative 50x? Good. A positive 10x. And a positive 15 divided by that negative 5 is a negative 3. This would actually be my final answer. This would be considered the derivative of the original function. Cool? Okay. So if you need to on this particular problem, pause the video, rewind to the beginning of this problem, take it slow, and make sure your work is matching my work. And as you do that, I am going to go get us another problem, so stay tuned. Okay, so let's look at this next problem. Still asking us to take the derivative, and I've got a quotient, which means we have to use the quotient rule. Excellent. So let's see what you remember. So we are taking the derivative of y. So remember, how do we work with the quotient rule? What's the first thing we're going to do? Yeah, we got to take the derivative of the numerator, which is 4x squared, and we multiply this by the denominator, and then we subtract, right? And then what? And then we just write the numerator, and we multiply it by the derivative of the denominator, and then, yeah, the denominator gets raised to the power of 2. So we're going to have 7 minus 5x cubed, and it's going to get raised to the power of 2. Right? Okay, let's keep working. Let's see what we're going to get. And by the way, if you just want to watch, then watch and then rewind the video and work it out with me and make sure you're agreeing. Right? Always a good idea. Okay, so the derivative of 4x squared, what is that? Good. That's just 8x. It's getting multiplied by the 7 minus 5x to the power of 3. And then you're subtracting what? Good. 4x squared. And then, yeah, you're taking the derivative of this thing, right? So what do we do first? We bring the power down. We reduce the power by 1. And then what? Yeah, you've got to take the derivative, right? And I'm going to put it off to the side here. You're going to have to take the derivative of what's in parentheses. So answer me that. What's the derivative of what's in parentheses? Excellent. Just a negative 5. Agreed? And now the denominator. So This is going to be 7 minus 5x. Now what happens between this 2 and this, or this 3 and this 2? Good, you multiply them together, which gives you that 6. With me? All right. So let's see what's happening. Y prime equals, still have the 8x, still have this 7 minus 5x to the power of 3. Now over here, after the subtraction sign, I am seeing, let's see if you notice the same, I'm seeing this 4x squared, this 3, and this negative 5 all being multiplied together. So the negative 5 times 3 is a negative 15, correct? Times the 4x squared. Good, that's a negative 60x squared. Following a subtraction sign makes this a positive 60x squared, doesn't it? Still being multiplied by the 7 minus 5x to the power of 2. And still have our wonderful little denominator. Y'all with me on this positive 60x squared? Again, the 4 times the 3, 12, times the 5, 60, x squared. But it's a negative following a negative, which makes it a positive, doesn't it? Okay, so short of writing this out twice and distributing and doing the same with that, is there another way I could try to simplify this particular problem? Yeah, some of you are like, well, last problem we factored out a GCF. So what about this one? Do we have a GCF we can factor out? Yeah, good job. Some of you are seeing it. So in the numerator, you can factor out the GCF, can't you? What's the GCF from the numerator? Yeah, the 7 minus 5x. Now, since this one has 3 of them and this one has 2 of them, yeah, you can only take out 2, can't you? So, we have in this case the GCF, which is 7 minus 5x to the power of 2, and that's what we're going to take out. So now we have y prime equals, what are we taking out? 7 minus 5x to the power of 2. Let's see what remains. So out of this part, before the addition sign, good, we've got the 8x, and that's right, we have one of these 7 minus 5x. There's 3 of them here, and you're taking 2 out, which leaves you 1 of them. Excellent. Plus, so after the plus sign, yeah, you're taking all of these out, which just leaves you a 60x squared, right? All over 7 minus 5x to the whole thing to the power of 6. Agreed? Okay, well this is a lovely little problem, isn't it? All right, what do you guys see? You're right, I can simplify in this parenthesis, or in this bracket I should say, but do you see anything else we can do to simplify? Notice in the denominator I have a 7 minus 5x. In the numerator, look at the GCF. Remember, this is being multiplied here. So what can I do with these? Yeah, I can cancel. So I'm going to wipe out these 2 from the top. I'm going to wipe out 2 from the bottom, which will leave me how many in the bottom? Good. 4 of them out of the bottom, right? Only 4 left in the bottom. 4 left in the denominator. Cool? Okay, so let's see. We have y prime equals, in this bracket, that looks like 56x minus 40x squared plus 60x squared all over this denominator. Now it's raised to the power of 4 because I canceled 2 from the top and 2 from the bottom. And when I look at the numerator, I can simplify these, the last 2 terms, and I get a positive 20x squared plus 56x. The whole thing is over 7 minus 5x to the power of 4. Cool? This isn't that bad. What you have to be careful of is taking it slow and one step at a time. I like to write every single step out. I don't like to skip anything, because if I skip a step, I could actually get this problem wrong. And I really don't want to have to go back and redo this particular problem. Do you? All right, so again, just take it slow as you're doing this particular type of problem. And I've got some applications for you, so I'll be right back.